So addressing modes and instruction sets we have discussed, and I told you this can be your part B questions, addressing modes and instruction sets. So today we try to cover simple programs with 8051. Okay, I think we'll directly move on to the some simple programs. You people remember what are the programs we are seeing, that the particular programs you are will do it in the lab. Are you clear? So we are going to discuss today only the lab programs. Okay, so not only for the theory but also for practical also, this particular thing will be covered. So yesterday I have put up the uh, unit 2 ppt already put up. Actually I have done some modifications and I have uploaded. Okay. So 60 participants were there. Okay, ma. We will start the class. People kindly listen, because this program, what I have given, we covered the two topics, addressing modes as well as the instruction set we have covered. Okay. Yeah, in addressing modes, we have discussed about the types of addressing mode: direct, indirect addressing mode, then immediate addressing mode, implied addressing mode, then registered base addressing mode, and all we have discussed. So instruction set also we have discussed about arithmetic, logical instructions, data transfer instructions, boolean instructions, program branching instructions we have seen. Now today we try to cover some simple programs. People try to listen. All these programs will be used for your practical. So during practical, we will explain only how to do the program. The logic of the program we were explaining today. I'm explaining. Actually, these programs, how you will do now, in 8051, you will use Scale compiler. So in Scale compiler, you will type your programs, and automatically, uh, by executing, you can view your outputs. So the Scale compiler have a procedure how to load the data and how to execute it, and all you will see. But now today we try to uh, cover some of the programs, that is basic programs in lab programming. Okay, so please people listen, ma. Okay. Vijay, sorry, not Vijay, Vijay Shri, by seeing 49. Yeah.
Yes, ma'am.
What is the first program, ma? Can you able to view the screen?
Yes, ma'am. 8-bit addition.
8-bit addition. Okay, so 8-bit addition we are going to add to 8-bit data. Actually this program, it's very simple program. We are not going to check any carry and all. We are going to give only the data which is without carry. Okay. Actually, by seeing that, how many ports are there, ma Vijayshri?
Uh,
What are
and
the ports?
port 0, ma'am.
Hmm.
And port 1.
Port 0 and port 1. Vijayshri, how many ports are there?
Only port 0, ma'am.
Port
P0.
0 in this program. Okay, port 0. Normally in 8051, how many ports are there?
4 ports, ma'am.
Port 0, port 1.
Port 1, port 2,
So I
port.
can view my outputs in ports as well as I can view. Okay. So you can mute your mic, ma. So please listen, ma. So here ORG000H, that is origin of my program. Actually, what is the difference between this microprocessor and microcontroller? Here you can use the label loop and all. You need not to calculate the address of each instructions. Even though we know, but we need not to calculate. Just putting that, we can use it as a loop. So ORG0000H. Now move a comma hash. Today Akash Singh is present. Akash Singh, Akash Singh is present or not?
Yes, ma'am.
Yesterday I have
Present.
asked him, what is Hashma? Hashma? Hash. What hash represents?
I'm two story.
Yesterday the same question I have asked you. Hash represents what?
Yeah, ma'am. To storing the registers.
Immediate
To storing the registers, ma'am. For
immediate data. I have to move my A value to what? 4E. Data. Hash represents always data. If it is if I am
oh,
moving 8 to 8-bit register, this will be 8-bit data. If I am moving to 16-bit register, that will be 16-bit data. So mute your mic, Akash. Move A comma hash 4E. So A equal to what is the value? 4E. Move R1 comma hash 0A5. Actually, why I said 0 put na, uh, before alphabets we have to put 0. So what is my R1 value? A5. So A is 4E, R1 is A5. Add A comma R1. Add A comma. Is it audible to you, my everyone? Add A comma R1. That means what? 4E plus A5 I have to calculate. Are you clear? 4E is my 8-bit data. A5 is also 8-bit data. Why I am putting before A0? Because alphabets, actually it's a hexadecimal to number. To identify that, I have to add prefixly 0. So add A comma R1. That means what? 4E plus A5. 4E plus A5, what is the answer, ma? F3. Are you clear? We all know after all arithmetical operation, my accumulator will store the answer. So what is my A value? 4, F3. I am moving my A to P0. So P0, you just see F3 value. I think they have given the value. Whenever the bit is 1, it will represented by a tick. I think you have seen what is my F value, ma? 1, 1, 1, 1. All 1 and 3. 3 means what? 0, 0, 1, 1. So my port 0 value is F3. Are you clear? Okay. The next one is 8-bit subtraction. I'm doing my subtraction operation. Again, the same process, but you have option of sub B. I think once again I will refresh that. Sub B means what, ma'am? If there is no borrow or no carry, accumulator minus my value which is given in the program. If borrow is there, A minus source minus carry. Carry is nothing but in subtraction we mentioned borrow. So here we have the instruction sub B. Sub B means what, ma? A minus R1. So first I am giving what is my A value? 45. What is my R1 value? 4E. You all understand? My compiler 8051, I am using which compiler, ma? Kale compiler. I think you can search it in net. In the Kale compiler, we don't have a case sensitivity. Okay, we don't have any case sensitivity, so I can put a small letter or capital letter, whatever may be, it will understand the coding very well. So move R comma 4E. So A sub B. Sub B means what? Subtract with borrow. If borrow is there, it will subtract accumulator minus R1 minus carry value. Or else what it will do? A minus R1 only. So A5 minus 4E it will calculate. So A5 minus 4E. What is my answer, ma? 57. Okay. So that will be stored in where, ma? Accumulator. After all arithmetical and logical operation, my accumulator will store the result. So A minus R1, accumulator will hold the value 57. I am moving that value to which port, ma? Port 1. You just see 57. 57 means what? 0, 1, 0, 1. Okay. And whenever the bit is 1, it will be put it as a tick. 7. 7 means what? 0, 1, 1, 1. This is my answer. Are you clear? End I have put. End is end of the program. Okay. Actually, some of the you all understand 8051. It's a very important coding in embedded applications because you have seen 8-bit addition. How many lines we require, ma'am? 1, 2, 3, 4. Within 4 lines, we perform 8-bit addition. But did you remember in 8085, we have written a very big program to get the data. So what happened now? By using this 8051, the coding, number of coding only required for the program. So programs and all, not a lengthy program. The programs and all very, very less. Only thing is you have to understand the concept. Without understanding the concept, and one more thing you can ask, actually in lab program, how they will give the data, na? Store the value in accumulator or store the value in port 0 or store the value in register R6. Depending upon that, you have to move the data. Can you understand? So here we are moving accumulator to port 0. In this case, we are moving the accumulator value to port 1. That we have to decide. Okay, now I have explained the sub B and this thing. Actually, what is the difference between the two? Same data only used, but here the accumulator content is less than R1 content. Have you all seen? Accumulator is less than R1. So here how we were subtracting now? Move A comma A is 4E, R1 is A5, sub B A comma R1, A minus R1. While I am performing 4E minus A5, my R1 content is greater. So automatically if I subtract, I will get the negative number. That's why the same thing, A5 minus 4E is what I am getting, 57. But at the same time, it's a negative number. So that's why what I am getting ma A9 here. Or you understand 1010, then 1001. So to indicate it's a negative number, we are putting to understand this. I have taken the same example and I have subtracted from less number minus big number. Similarly, smaller number minus bigger number. And here also I move my accumulator content to port 0. Are you clear, ma? Okay. Okay. This is for A5 minus actually what we get, ma? 57. But here we are putting a negative number, ma. How will you find out the negative number? We'll keep the MSB bit as a 1. How will you take a 1's complement and a 2's complement to find out the negative? The same thing, same procedure only we are following. We have to complement the bit for 1's complement. 2's complement we will add with the 1. If carry is generated, we will ignore the carry. The same procedure what we followed in 1's and 2's complement. The same way. So A9 is nothing but negative number of 57. Okay. The next instruction is Neetu Priya. Tell me, ma.
Arti.
Ma'am, can
Yeah.
you please tell me what is this ORG again, ma'am?
ORG.
ORG.
ORG is nothing but origin. Actually, whenever I am starting my program, I have to allocate the memory space for my program. That is very important. So ORG 000H means in term here we all know internal RAM, internal ROM, external RAM, external ROM is there. So while you are executing Kale itself, if I allocated the memory space, it will take the 2 KB memory space will be allocated and all. So to specify to start the program, we always use ORG. ORG is nothing but to start the origin of the program. We are starting ORG 000H. Actually, we are starting from the memory 0000H. Actually, it will take the memory space randomly. That we are not specifying. Actually, in Kale compiler, we have only 2 kilobytes of memory. It will allocate it. Whatever program I am writing, for that it will take only minimum of 2 KB memory. Can you understand? So
Yes,
that is the way they will allocate the memory. And one more thing, here we are not specifying any address for the program. Can you understand?
okay, ma'am.
Address will not be specified here. Here just we will write the program. Abhirami,
Yes, ma'am.
Yama.
Ma'am, port 0, port 1 number இஷ்டம்தானா ma'am? எது வேணா யூஸ் பண்ணிக்கலாமா ma'am?
You can use it anyone, ma. Actually,
Okay.
the question will be different. For example, they ask you to add to 8-bit number and store my result in port 0 and store the result in port 1 or store the result in R6 register. They will specify it. So according to that, we will find out. Are you clear?
Okay, ma'am. Thank you,
Okay.
ma'am.
Now 8-bit multiplication. You see, only 6 line of program I can perform 8-bit multiplication. Move. What is my? You all know we will use the B register only for multiplication and division. So other time we won't use any B register. You can see the entire program. The entire program, the B register will used with along with mul and div instruction. So A accumulator is 3. B register value is 4. Okay, mul AB. Actually, we are performing A into B. So A into B na 3 into 4. So 3 into 4 we all know. Actually in decimal 12, but well we are performing in hexadecimal. The 12 value is what ma C. Okay, so C means we all know here we are not it is not exceeding 8-bit data. Sometime depending upon value it will exceed 8-bit data. So at that time what happen now, the lower order byte will stored in accumulator and higher order byte will be stored in B register. But here 3 into 4 what is my value ma? C alone. So C will be stored only in accumulator. Here no higher order byte. Set B PSW 0.4. I think Jerson, register number 39, Jerson. Jerson, are you there, Jerson?
Yes, ma'am.
Yeah. Jerson, did you remember set B PSW 0.4? Why we are using this instruction here? To select when I'm setting the program status word 4th pin and 3rd pin, what is the main purpose of that? Program status word 4th pin and 3rd pin. Jerson. Program status word 4th pin and 3rd pin. What is the purpose? Jerson?
Yes,
Playing.
ma'am. Kerala. I don't know, ma'am.
You don't know. Simple answer from you. Actually, at the end of this session, the same question I will ask. You try to answer it. Why the program status word 4th pin and 3rd pin? What purpose you have to use it? You have to answer my question. Answer, can you answer? Understand? You have some 40 minutes time. Before that, identify what is the use of this PSW. Okay. Now you
Okay,
mute
ma'am.
your mic. Mute your mic. Okay. Set B. We all know it is a Boolean instruction. Set B means ma set the bit. I have to set which bit ma? Program status word 4th bit I have to set. You all know the program status word. What is the purpose of the program status word now? Program status word will reflect the flag register. Wait ma. So set B na, set the bit of program status word, 4th bit I am setting. What is program status word na? It is nothing but a flag. The content of flag register will be reflected in program status word. Are you clear? So we all know what are the flag register. Carry flag we are using, auxiliary flag we are using, overflow flag we are using, parity flag we are using. So apart from that, the 2 more bits they are allocated for the bank selection. We all, did you remember bank selection? Because here we don't have a registers alone, we have a bank registers also. What is bank register now? Totally we have 4 banks, each bank consisting of 8 registers. So we have allocated nearly 32 registers for bank. So in program status word, if I am putting the 4th bit and 3rd bit 0 0 na, bank 0 will be selected. 0 1 na, bank 1 will be selected. 1 0 na, bank 2 will be selected. 1 1 na, bank 3 will be selected. Okay. Now set B PSW 0.4. I have set the 4th bit of the program status word. So my value is 1. I think 46 Kausalya. Kausalya? Kausalya? Kausalya, are you here, ma'am? Hello?
Yes, ma'am.
Now which bank will
Hello?
be selected? Tell me which bank will be selected in this program, ma'am. I have set the bit of program status word, 4th bit I set. So 4th bit value is 1. So I didn't set the 3rd bit. So obviously 3rd bit value is 0. 1 0 na, which bank will be selected? 1 0 na, which bank will be selected, ma? Kausalya? People listen, ma. Can you able to see? Program status word, 4th and 3rd bit. 0 0 0 1 1 0 1 1. I think, is it visible, ma? 1 1. So 0 0 na, bank 0 will be selected. 0 1 na, bank 1 will be selected. 10 na bank 2 will be selected. 11 na bank 3 will be selected. This is the concept. Okay, now we have set the fourth bit. That means what? This value will become 1. Okay, so I didn't set the third bit. So obviously my third bit is what ma? 0. So 10 na which bank will be selected, Kausalya? 10 which bank will? Huh?
Bank 2, ma'am.
Bank 2. All you remember or not? We all know all this bank have how many bytes ma? Actually, can you understand? People understand. 10 na bank 2 will be selected. Okay, and one more thing. You all know this bank having a structure of this thing. Bank 0. Okay, bank 1, bank 2, and bank 3. Okay, so each bank having address what ma? R0 to R7, R0 to R7, R0 to R7, and here also R0 to R7. You all understand my answer 002 07 will occupied by this address. Then 08 it will start. So 08 will be occupied by R0 address. So 08 na 08 09 0A B C D E. Okay, till E it will be occupied here. Then from F it will occupy the bank 2. So F, then after F what will be the value ma? After F what will be the value? 10 11 12 13 14 15. Okay, F 10 11 12 13 14 15. So till 15. Okay, and from this 16 16 17 18 19 1A 1B 1C. So this is the way it will occupy the. So only thing is we have to remember the address of this. Are you clear? So you people always remember each bank having what ma? Bank 0, bank 1, bank 2, bank 3. Each bank having R0 to R7. Okay. Same thing I have put it as a PPT. Okay. Now set B PSW 0.4. I have said which bit ma? Which bank is selecting now? Bank 2 is selecting because 10 bank is 2. So in bank 2 I am moving my accumulator value to R6 register and I am moving my B register value to R7 register. Are you clear? So only thing is somehow they will ask this question na, perform a 8-bit multiplication. Store my results in bank 2 registers of R6 and R7. This is the question. Okay, if my question is store my results in bank 3 registers of R6 and R7. Now what is the change in the program? See, the question is perform 8-bit multiplication. Are you clear? Store the result in bank 3 register. Bank 3 register, sorry, perform 8-bit multiplication and store the result in bank 3, which has to be stored in R6 and R7 register. So I have to store my result in bank 3. So what is the change in the program? What
We
is
have to include PSW.3.
Very good. Who have told ma?
Me, ma'am. Need to Priya.
Neetu Priya. So what you have to put? Set B PSW 0.3. Are you clear ma? Set B PSW 0.3 now. I have to set the bit of program status word third bit. Good Neetu Priya. So this is the change. So you need only understanding the logic only you can able to write the program. Are you clear? The next one is 8-bit division. Okay, again the program is not lengthier than this, but in this program a small change. What the small change now? Instead of storing in bank register, I have to store it in my internal memory. Are you clear? This program what they na to perform 8-bit division. Okay, store my quotient in 60H memory and store my reminder in the next memory location. So here we have to store the data in internal memory. Previous program I have stored my result in first where I have stored ma previously I have stored in port 0 and then I have stored in port 1 and then I have stored in bank. I have concentrated on bank, not registers. And next I have to concentrate on memory, internal memory I have to store. Okay. Now move a comma hash 04. What is my a value? 4. What is my b value? 2. Div ab. Div ab means what ma? 4 divided by 2. Only thing is you understand here, my quotient will be stored in accumulator and my remainder will be stored in b register. This is the only thing. My quotient will be stored in accumulator and my remainder will be stored in b register. So 4 divided by 2. 4 divided by 2, to understanding only I gave small number. Okay. So remainder is 0 and quotient is 2. So accumulator will hold 2 and b will hold the value 0. Okay. Now move r0 comma hash 60. So what is my r0 value? 60. Move at r0 comma a. At means what? Indirectly I have to specify the address. Indirectly means what? r0 what I have specified? 60. So I have to move my accumulator content at r0. At r0 means you go and see. Here I have put address. I stands for internal memory. I has 60. In 60, what I am moving ma? Accumulator at r0. 60 memory location I am moving which my data. Remainder I am moving. Sorry, quotient I am moving. Quotient hold by accumulator. So 02 will be stored here. INC R0. INC R0 means what? Increment the R0 value to 1. So R0 will become 60 to 61. Move A comma B. That means B will hold what ma? Reminder. Here there is no reminder, but even some of the program we have a reminder. So at that time I have to move my B value to accumulator and from the accumulator to R0. You all know B register we don't have a any other register movement, but accumulator I can move to registers. All the registers I can move. So I can't directly move at R0 comma B. I can't use the instruction because we all know B register mainly to hold the data, that is at the multiplication and division. So don't use move at R0 comma B. That is a invalid instruction. Are you clear, ma? Can you understand this? Okay. Now the same program. Okay. Instead of here, how they are asking the program now, perform 8-bit division. Okay. And assume that R1 register holding the address of 75. Move the particular data to the internal memory of 75. Move the quotient to 75 and move the remainder to the next memory location. So what you will do, ma? What I have to do? They have assumed or I have to move to which memory location? Instead of 60, what they specified? 75. So instead of 60, what I have to put here? 75. So my R1 is 75 now. They are saying R1 hold the value of 75 now. Move R1 comma hash 75. Move at R1 comma A. INC R1. Move A comma B. Move at R1 comma A. Okay. Or else sometime the question is very direct. Store my quotient in 75th memory location and the next consecutive memory location store my remainder. So what you have to do? Just put 75 here. Here what you have to put? No other change in the program. Are you clear or not? Because all other will be depending on that. Have you understand this program? Have you understand? Afridi. Afridi? Afridi, are you here, Afridi?
I'm at international, ma'am.
Yeah, Afridi, why you didn't attend the classes? Actually by seeing participant list I have seen. Why you didn't attend so many classes, ma? Why you missed the classes? Afridi? Afridi, can you able to hear my voice? Afridi, can't you able to hear my voice? Yes. Afridi, Any problem in your mic? Okay, you just I have to inform some of the students have taken the leave, long leave. I have to inform to your year coordinator because taking this much of leave won't help for you for to gain your marks. Are you clear? Because all mode of thing is transferred into online mode. So you people have to come to the class regularly. Please allocate doing the work even when you are coming to the college and all. What work we will do, the same work only we were allocating. So try to finish it off that. Shashank. Shashank?
Yes, ma'am.
Yeah, Shashank. Now assume I'm giving A to 5. My A value is 5. My
Yes,
B
ma'am.
value is 2.
Yes, ma'am.
Okay. Now you tell me what is my answer in 6, 60 and 61.
60 and 61. Move back. Ma'am, once again, A and B value.
A is 5,
Hmm.
B is 2.
5B is 2.
Hmm.
Ma'am, in 60, it will come RO. So, ma'am, in 60, it will come 2
61.
and 1, ma'am.
Very good. So the thing is, you understand that? Can you, good ma, mute your mic. So you people understand it's your lab program only. So whatever I am explaining today, all your lab programs only. You have a lab definitely. Don't think that in this pandemic the lab will not be there. Okay, because in curriculum each and everything is very important. So this lab and power electronics lab is there in your semester, but this particular subject you are learning in this semester itself. Okay, now the DA instruction. The DA instruction means decimal adjust accumulator. So decimal adjust accumulator now, while I want to perform addition, I want to get my addition in a BCD, I have to get a user DA instruction. I think very easily move A comma 47, move B is 25, add A comma B. Actually, you have seen that they are using add A comma B. Actually, we'll wait. We have a add A comma B is there because we have a 8051 where the some instructions are we are using Kyle compiler. Atmel only we will be supporting. Yesterday I have taken from the PPT. We will see whether that particular instruction is supporting. No ma. Add A comma RN is there. Add A comma B is not there. I think they have put wrongly this. Okay. Actually, what is the change is there now? We don't. Have you seen that? We are. What are the instruction in add we are using? So sorry. I have to take down. For just see add A comma RN is there. Add A comma direct is there. Add A comma auto array is there. Add A comma hash data is there. We don't have add A comma B is not there. Okay. Actually, B is always used with multiplication and division only. I think this slide I have put now only I noticed that it's not add A comma B, add A comma R only. Okay. Because we don't have add A comma B instruction. Mali AB, div AB is only available. Okay. Actually. So how we can write this program now? 47 plus 25. 47 plus 25, what is the answer, ma? Actually, the answer is 60 here, but what we will get? 72. Okay. I think I will share the whiteboard. Okay. So move A comma hash 47. Okay. Then move R0 comma hash 25 is there. Okay. Now I have to add the two BCD number. We all know I can put what ma? Add A comma R0. I have to add 47 plus 25. You all understand? 47 plus 25. Normal BCD, it says 72. But in hexadecimal, what is the answer? Na? 6C. Okay. 6C in hexa. Okay. 72 in BCD. This is in BCD. So here, after this, what is my accumulator value? Ma? After adding this instruction, what is my accumulator value? 6C. Okay. But actually what it has to do? 72 only it has to go. So what I have to do to get 75, which instruction is used? DA, decimal adjust accumulator. So after this, what is my accumulator value? 72. Are you clear, ma? So this is a DA, decimal adjust accumulator. So I'm loading my accumulator with 47, R naught with 25. I'm adding 47 plus 25. Actually, 47 plus 25 in hexadecimal it is 6C. Okay, in hexadecimal it is 6C. But if I perform, we all know here 6C means what it will do. It is greater than 9. So greater than 9 means I have to add a 6. So after that, I will get 72. That is the internal operation of DAA. Okay. So this is the instruction. Okay. So here that is a small change. It's not move B comma, move R1 comma or R0 comma or R2 comma. Any register from I can use R0 to R7. Okay. Next one is 16-bit addition. You all know what is 16-bit addition, ma? I'm going to add 3CE7 plus 3BAD. I'm going to add these two numbers. So by adding to this two number, my answer is what, ma? 78, 74. Okay. I think here I am explaining this. Okay. Now I will explain with this. Okay. So first what I have to do, I have to add E7 and 8D separately. Then I have to add, can you understand or not? Can you able to see this? Can you able to see, ma? Yeah. First I have to add E7 and 8D first. Okay. Then I have to add 3C and 3B. I think this program. Can anyone explain? Shalini, register number 77. Shalini. Shalini is there? Most of them are collecting through mobile data. Shalini? Okay.
Ma'am,
Can you able to explain this program? Ma? இங்க வரீங்களா வாங்க வாங்க இதே சிஸ்டம் எடுத்துக்கிறீங்களா ஓகே 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 okay. Yeah, tell me, ma. Move A comma hash E7. Can you understand? It is a 16-bit addition. I think mute your mic. Mute your mic. Okay. Shanmuga. Shanmuga. Shanmuga is absent today.
Ma'am.
Yeah. Can you able to explain this program, Shanmuga? It is very difficult. Yeah, explain it. Yeah. What is the program now? I am going to add 3CE7 plus 3BAD. I am getting one result. I have to store my lower order byte in R6 register and higher order byte in R7 register. So you please kindly explain this. Explain, ma. Move A comma hash. What happened? I think your this is not connected. Pandya yeah, will you explain it? Pandya okay. Listen, ma. Yeah, tell me. Okay, listen. Mic problem. Okay, 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 ma. I will explain it. First, this is 3CE7 is 116-bit data. 3B80 is another 16-bit data. I'm going to add this 16-bit. We all know here my accumulator length is what ma 8-bit only. So I can't able to perform 16-bit addition in stretch. So what I have to do, I have to split my data into 8-bit. So first I have to add this E7 plus 80. This is my one 8-bit addition. Then I have to add 3C plus 3B. That is another 8-bit addition. Then finally I will get one result. So that I have to move my value. So first what I have to do, I have to perform E7 plus 8D addition. Okay. So move A comma hash E7. So we all know put 0 prefix. So add A comma hash 80. So I'm adding E7 plus 80. Okay. So adding E7 plus 80. What is my answer ma? 74 I'm getting. But you understand this? By adding E7 plus 80, carry will be generated. Actually 174 will be the answer. So but my accumulator can hold only 74. So that accumulator value I have to move to R6. You just see here my R6 value is what ma 74. My R6 value is what 74. Okay, now carry is generated. So to that what I have to do, if carry is generated or not, what I have to do, the next instruction, move A comma hash 3C. 3C na move A comma hash, add C A comma hash. So C means what? If carry is generated, now my carry value is 1. Otherwise, my carry value is 0. So for all 16-bit instruction, first to put add. The second addition you have to put add with carry. If carry is generated in the program, the carry value will be 1. If carry is not generated, the carry value will become 0. So 3C plus 3B and carry is also there. So all by doing the perform the addition, what is my value? 78. So that 78 should move to R7. So you just see I am moving my accumulator value to R7. So what is my accumulator value? R7 value 78. So 74 lower order byte will be stored in R6 register and higher order byte is stored in R7 register. You all know this is accumulator, B register, stack pointer, data pointer, program counter, states, and program status word. Okay, these are all system related registers and these are all bank related registers. Okay, can you understand this 8-bit addition ma? Sorry, 16-bit addition. I think the program is very easy for you. The same thing is 16-bit subtraction. Okay, so 16-bit subtraction in sense means again I'm actually this is minus not plus. Actually this is minus. Okay, so here 3C is 7 minus 3B80. I'm subtracting this number. Okay, we all know subtraction, subtract with borrow only. The only instruction is that. So sub B only you have to put. So E7 minus 8D I have to subtract first. So after subtracting, what I have to do, if borrow flag is or carry flag is set, automatically it will take or else it won't take. First case it the borrow flag will not set. So there is no problem. Okay, so but we have only sub B instruction. So I am moving my accumulator content to R6. Then I have to subtract 3C minus 3B. So after subtracting, what is the value? I am getting 0, 1. So first 8-bit I am getting 5A. The next 8-bit I am getting 0, 1. You all know my accumulator can hold only 8-bit data. So first this 5A should move to where ma? R6. So now you see R6 is holding which value? 5A. Then you see what is my higher order byte ma? 0, 1. That should move to R7. Accumulator content to R7. So you just see R6 is 5A, R7 is 1. So you just see within 4 to 5 lines, we have written the 16-bit subtraction. Are you clear ma? Have you understand this? So 16-bit addition, what instruction I used? Add A comma hash, add C. But here we have only sub B instruction. We don't have a sub instruction is there. So subtract with borrow is there. So sub B A comma hash 80, then sub. So all these cases, I am giving my data directly to the register and I am performing my addition or subtraction. Okay. Now we will see the next program to add and store the result in register bank. Actually, this question I have asked. Very simple question. Move R0 comma hash 45. Okay. Then move R1 comma hash 50. Okay. Now move A comma R0. Okay. A comma R0 now. What is my A value now? 45. Add A comma R1. Add A comma R1 means what? 45 plus 50. We all know 45 plus 50. What is the answer ma? 95. So 95, I have to store it in which bank? Na? Bank 4. So bank 4 means what I have to do? Bank 4 means what ma? 00011011. So I have to set my fourth bit as well as my third bit of the program status word. So what I am putting? Set B program status word dot 4, set B program status word dot 3. So I am putting both the so move I am moving in which register ma? R7 register. So accumulator to R7. The R7 address is what now? 1F. I put it that bank na in that. If I go and check it in, I can directly check it in this. This also I can check, and through this way also I can check. I can check my all register have a address. Accumulator have address. B register have address. R0 to R7 have a address. So we are all saying this 8051 having all the special function registers as well as the general purpose registers are all bit addressable register. That means each and every register having address. R0 means address, it have one address. R1 means it have one address. So this bank to R7 address is what ma? 1F. So that 1F will be stored the value 95. Okay. Now if I want to store it in bank 0 na, what I have to put here? Clear PSW 4.4, clear PSW 0.3. That means what? CLR. CLR means what ma? Clear. Clear the fourth bit of program status word. Clear the third bit of program status word. Automatically which bank will be selected? Bank 0 will be selected. Are you clear? Okay. The next one, to perform arithmetic operation and store the, I think people listen, tomorrow you have a one quiz in Kahoot. Are you clear? Because tomorrow last hour only. Every time I'm seeing in the last hour, so many people are getting absent. Actually, before that you have a elective hour, I think so. After finishing your biomedical elective and Python elective, some of the people are left. Don't think that you have a class from 12 to 1. You people know, for all second year and third year, even for first year also, we have Saturdays colleges. Only for final year, you have Monday to Friday. Even invariably, this Monday is holiday for you. So consecutively, Saturday, Sunday, Monday. 3 days you are getting holiday. You think, understand? You have to do your project. You have to get your placement, and you have to concentrate on your studies. You have to complete your assignment on time. All this has to be duty has to be served by you. Don't think this time Tamil Nadu have announced for all the arrear students, they have declared pass for all the people. Every time this won't be happen. So some of the students have kept their name as a EPS and had attend the quiz and all. I don't know how these people were doing like this. So don't imagine every time the same sequence will be getting. Okay. So you have to have so many works for you. So I think you people have to do your work properly. Okay. I think you have to submit the assignment. Still now, I don't know how many of you submit the assignment. Please raise your hand, ma. How many of you submitted the assignment? Please raise the hand. People, please raise the hand.
LMS ல அசைன்மெண்ட் சப்மிட் பண்ண முடியல மேம்.
என்னோட சப்ஜெக்ட்லயா?
எஸ் மேம்.
என்னோட சப்ஜெக்ட்ல சப்மிட் மத்த சப்ஜெக்ட்
இல்ல மேம், எந்த சப்ஜெக்ட்லயுமே சப்மிட் பண்ண முடியல.
பட் இன் பைத்தான் some of the students have submitted ma.
நேத்து சப்மிட் பண்ண ட்ரை பண்ணேன் மேம், ஃபுல்லா சுத்திட்டே இருந்துச்சு, சப்மிட் ஆகல.
விஜயஸ்ரீயா ma? Who is speaking ma?
சரண்யா மேம்.
Sharanyava. Saranya, actually, that is one problem. Everyone waiting for the last day. Net problem will be there now. You can't able to upload your assignment. You all know, second year, third year also has to submit the assignment by 7th and 8th. So people kindly, one thing you would have to do, LMS, you can try to upload in some early morning and all, okay, or else in night. I think that time the users will be reduced, so you can upload it easily. Are you clear, Sharanya?
Okay,
Sharanya,
okay ma'am.
you have your assignment, Sharanya?
Yes ma'am.
Completed. What you want help you do ma? You kindly send your assignment to my WhatsApp number. Okay, I will try to upload it.
Okay ma'am.
Saranya, are you clear, ma? Please listen. And one more, Saranya, the GB should be not GB. The MB of the maximum size of the assignment should be 35 MB. So beyond 35 MB, you can't able to upload. 35, 32 MB only. People listen. This is not for one particular student. Everyone who are all in LMS. I told you. I think I am have to show that. We'll continue this next class. I have put that one for you. Actually, I decided to conduct one practical session for you. Yesterday,